All right, section 7.1. We're going to talk about a thing called... Yeah, I know. I thought I... Oops.
Oh. You made it
there we go. All right. Okay, everybody ready now? I'm glad you're paying such close attention. We're going to talk about ratios. All right, so basically when you talk about a ratio, what is it? Like, what pops in your head when you think of a ratio? A fraction. Very good. That's what I was looking for last class, and nobody would say it. They said other things. What are some other things that might pop in your head when you think of a ratio?
Hard work.
Probability. Like, how, like, kind of like, what's the ratio from you'll land on this or land on this?
Okay, like a chance probability from one to the other. Okay, what's another one?
Where it's like a number and then two dots and then another.
Okay, yeah, that's a good one. That's good. We're going to talk about that, definitely.
Gambling. Like you have
Who?
a certain gambling.
Oh, yeah.
Gambling.
Odds.
Okay, odds, right? Compare one thing to another, right? So it's a comparison, isn't it? You compare one thing to another. Yeah, you could do, like I did a problem last night, an SAT problem last night. It was about rolling the dice, and this kind of thing. And so it's probability, it's a comparison, and that kind of thing. All right, so also I'll just throw this in here. In algebra, a lot of times you'll see them talk about like rational expressions or something like that. And in my experience, I probably heard a teacher say a whole bunch of words and I had no idea what they were saying. I figure I'll just let them say it, and I'll figure it out some other time, okay? But what if they talk about rational expressions? When they talk about rational, what word, now there's probably a couple words in here, but what word that we've talked about up here is in the word rational? It's pretty easy, ratio, okay? Yeah, like I said, the word we talked about up here. So it's a ratio. So when we talk about a rational expression, what do you think these expressions have in them?
Fractions, expression,
Ratio.
Yeah, but what's a ratio? Fractions, right. Okay, so basically they're algebraic expressions with fractions in them, okay? So when somebody talks about a rational expression, we're talking about things that are have fractions in them. Make sense? Okay. Would you say, Ben? You said irrational. Did you say irrational? Somebody said irrational. You ever hear of an irrational number?
Yes, like the
Okay.
square root of like 91.
Yeah, the square root is something that doesn't come out even, right? Okay, for instance, I'll make it easy instead of 91. Let's just say the square root of 5. You put this in your calculator, it's going to be like 2 point something. But guess what? That decimal will never repeat. Listen to me. Don't talk while I'm talking there. Thank you. The decimal will never repeat, and it will never establish any kind of a pattern. All right, so that would be an irrational number. Irrational numbers like pi, right? An irrational number cannot be written as a fraction. That's why it's irrational, means it's not rational. You follow me? So if it's rational, it can be written as a fraction. I'm going way off board what we're doing today, but I'm running with it, okay? So but anyway, this is an irrational number. Pi would be an irrational number because it's not just 3.14. What is it? It's 3.14159, blah, 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 blah. And it just, you memorized it to 30?
Yeah, like
You did?
around 30.
Wow.
Say it.
That's all I know. Do you know it now? Do you know it now?
Decide it.
Well, I have no way to even double check to see if you're right.
Google it.
All right, hold on. Hey, wait a minute. All right, so I don't know if that's all in there. Okay, go ahead.
Okay. 3.14159265358979323846264338 something.
Hey, I'm still impressed. That's pretty good. So how many places did we go? To the three. Would we go right there, right?
She misses.
No, there's two.
Did we get to the 3 too? Did we get to the 7?
846264338. I think it's 7.
Nope, two.
You're close. 327.
327. Something.
Keep going. Keep going. Can you go further? After 327?
I think it's like 5 or something.
So how far did she actually get? She got to the 3, didn't she?
Yeah.
So count that up. How many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
No, I had it up to there, but I just forgot to.
It's like 20.
I lost count. It's around 28. 27, 28. That's pretty good. I'm impressed. Give her a hand. Yay, Rachel. Okay, enough nonsense on pi. So let's talk. Shh. All right, guys, please. All right, let's talk about proportions. Let's talk a little bit more about that. How do we write a ratio? For instance, if you write like 3 over 4, that's a ratio. You could say this. You could say 3 to 4, TO. All right, or you could say, who said this with the little dots?
Me.
Okay, it's a colon, right? So 3 to 4. You could write it either way. So when you talk ratios, you write it 3 to 4 this way, 3 to 4, 3 to 4. Means all the same exact thing. It's a comparison. We're comparing one to the other. All right, let's count up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We got 10 girls. Okay, and we have 1, 2, 3, 4, 5, 6. Okay, that works out nice. And then the boys, not counting me. I like to come out. I like it to come out even. Oh, that's right. I'm not a boy. Right? All right. Anyway, so here we go. If I wanted to make a comparison, listen. If I wanted to write a ratio of boys to girls in this class, my G is looking terrible today, isn't it?
Yes.
That's better. Okay. If I write the comparison or the ratio of boys to girls, how would I write the ratio of boys to girls? 6 over 10, or it's a lot better if you simplify it and make it 3 to 5. Okay? Agreed? Now look, so if I said what is the ratio of boys to girls in this class in simplest terms, you would say 3 to 5. Does that mean there's only 3 boys in the class and 5 girls? No. It's a comparison. It means what? What's the phrase? For every, right. For every 3 what? Boys, there are 5 girls. Or you could say it the other way around, okay? Listen to me. Right, like Khan said, we don't want to get morbid though. All right, so here we go. Shh. Let's get back on track. Let's get back on track. Matthew. Okay. So if I wanted to do the comparison of boys to girls, I see 3 to 5. If I wanted to say girls to boys, then how would I write that? 5 to 3. What if I wanted the boys to the total number of people in the class? How would I write that? Okay. Yeah, let's do the actual numbers. It would be, well, actually, let's do the ratio part. Okay, so what's the ratio part of the boys?
6.
No, just the ratio part, not the actual number. 3 to what? It's not to 5, because 5 is not the total. What would it be? 3 to what?
16.
No?
8.
3 to 8.
Well, there's actually 16 people, but when I'm just talking about the ratio part, it's 3 to 8. Now, look, you could have said, no, what am I doing? Oh, that's right. You could have said 6 to 16, couldn't you? But then you reduce it. What did you reduce it to? 3 to 8. So what did we do to find the total? We just added those two things up, right? Just like we would have right here. Does that make sense? Okay. What if I did this? What if I said next door they have the same exact ratio of boys to girls in the class as we do in here? Okay, but over there they have 25 girls
Whoa.
over there. Okay. It's a full class, all right? So they have 25 girls over there. Let's do a question mark. How many boys, that's supposed to be a B, how many boys are in that class? So what do? What's the ratio? They got the same exact ratio as we do in this class. So I want to find how many boys. So let's go boys to girls. So what would it be? 3 to 5, right? Equals. Now what are we going to put over here?
X.
Right, okay, X. I tell you what, let's do this. Let's put B for boys, okay? And over what? 25. Okay, now you could do this a couple ways.
15.
All right. You could, and we're going to introduce this in a second, and we'll do it right now. You could cross multiply. Now, you could just multiply both sides by 25. That would be fine. Or you could cross multiply. In some situations, it's easier to cross multiply. In this situation, I would just multiply both sides by 25, tell you the truth. But we could do this, right? So if we cross multiply, I always like to put the variable on the left-hand side. It's up to you. So I would make this 5b equals what? 75. That's supposed to be a b. Looks a little ugly. All right, and then divide by 5, so b is what? Divided by 5? 75 divided by 5? It's not 50. It's 15, isn't it? Okay. So that means if they had, listen to me, if they had the same ratio as we do over here of boys to girls, which is probably not very accurate, but let's say it was, then we could figure out how many people they have over there, how many boys there are. Does that make sense?
Yeah.
We could also figure out the total. What would the total be?
4.
It'd just be what? 25 and 15, so the total number of people over there would be 40. It'd be 40, okay? Does that make sense? Okay, let's do something else. You could compare more than just 2 things. You can compare 3 things. But once we start comparing more than 2, we quit using the fraction for the most part. So if I wanted to compare 3 things, let's just go letters this time. I could compare A to B to C. All right, you could do that. What's something that we've been talking about a lot this year that has 3 things in it?
Triangle.
A triangle. Okay, so let's draw a little triangle here.
Proofs have to be.
They do?
Yeah.
Okay, let's say we had a triangle right here, and they actually have some numbers that makes it works out real nice. Let's say this is the ratio of the, let's say the ratio of the angles of this triangle are 3 to 4 to 5. Does that mean, listen to me, does that mean that this angle is 3 degrees, 4 degrees, 5 degrees? No, of course not, okay, because it couldn't be the angles of a triangle if that's what we had right here. What it means is this. Let's pay attention. Matt, I'm serious. You need to settle down, pay attention, okay? You're like off the wall. So watch. This angle right here is not 3 degrees, but what it is this. It's 3 times a certain number, okay? This angle right here is what? 4 times, not just any certain number, but what? The same exact number, okay? And this number right here is, right. Okay, you follow me on that? For instance, if that room over there had twice as many people, let's say twice as many people, we have, what did we say we have in here? 16. Let's say it had 32 people over there, okay? So basically, the ratio is the same, but they have 2 times as many people as we have in here. You with me? So that's kind of what that 2 would be. So instead of 3, I'll call this angle 3, call it x, right? Because it's 3 times a certain number. Instead of calling this angle 4, we would call it what? 4x. Instead of 5, we would call it 5x. All right? What we have to do is we want to find out each of these angles. Listen.
You just said add them up. Well, if you like add them all up and set them to 180.
That's all you do. Because look, this actually represents 3 times this unknown number represents the actual degree, the measure of that angle. Okay? It's not 3 degrees. It's 3 times a certain number. This is 4 times that same number as that angle. This is 5 times that same number as this angle. You with me on that? So you're exactly right. So you just add them up, set them equal to 180. Let's do the math real quick. So 3x plus 4x plus 5x equals 180. And now we're going to solve for x. Now once we solve for x, that's not really what we want. We want to find each of these angles. Okay, we'll plug it in, exactly. So what do we get? 7 and 5 is what? 12x? What's that? What's 180 divided by 12?
15.
It's 15? Okay. So x is 15. That's not my answer. I want to find all 3 of these angles right here. So it's not that hard. So this is what? 3 times 15, which is 45 degrees. Okay, this is 4 times 15, which is 60 degrees. This is 5 times 15, which would be 75 degrees. Now, if you really didn't want to do that 5 times 15, you could have done what? Added those up, taken away from 180. But do they all add up to 180? Yep, they do. Okay, because that's 120 right there, and 60 is 180. So, yeah, it works out. So, if you have a ratio of 3 to 4 to 5, and if it's a triangle, right, there's 3 angles, so what do? You know they add up to 180, so it's 3x plus 4x plus 5x equals 180, and you're good to go. What if it was 4 sides, and they had compared it to D? Then it would be whatever this number is, x plus this x plus this x plus this x equals what? Not 180, but 360, right, because if they were the interior angles of a quadrilateral. Make sense? That's not so hard, is it? All right, now we did a little bit of cross multiplication earlier. You kind of beat me to the punch, but let's do that. Now they kind of give some fancy words to cross multiplication. They still use the word cross, but they call it cross products of. They just call it the cross product property. I probably will never refer to it like that. I'll probably just say cross multiply. There's another way that they call this. They call it watch this. They call it the product of the means and the extremes. What's that? The nicest? What? Oh, the means. Oh, right. I got you. Yeah. Well, that was a Khan Academy joke. Remember he said that yesterday? Okay. So anyway, what does that mean? It means this. Watch. If I have A over B equals C over D. The means and the extremes, they call this, and in fact, I don't even know which one they call it. They call this one the extremes, A and D the extremes, and they call B and C the means. All right, for whatever reason. I think I know why. I'll show you in a second. But watch. Actually, I don't. I don't know why they call it that. I think I figured it out some time ago, and now I completely forgot why they call it that. But I never call it that. They just do in the book sometimes. So, but if I wanted to work this out, what would I do? Right? Cross multiply. Did anybody ever show you why that works?
No.
What would it be? It would be AD equals what? Equals BC. Now watch. Let's just do some algebra on it and just do some regular algebra on it. Let's do the D. What are we doing? We're dividing by d, aren't we? It's c over d. How do you get rid of something if you're dividing? You multiply. So, oops, it's supposed to be a d. So I multiply by d over 1. So what do I do over here? Multiply by d over 1. All right, so I got rid of the d. Let's get rid of the b. How do I get rid of the b? Multiply by b over 1 here. That cancels out. Multiply this by b over 1. Look what we get. dA or what? AD. And we get what? BC right here. So we just did some regular algebra steps here, didn't we? To get this. But do you want to go through that mess every single time? No. If you look at it, it's a lot easier saying, hey, why don't I just multiply diagonally right here, set them equal to each other, and then I've got the same exact thing. Agreed? It's just a little bit quicker, streamlined, way of figuring this out. You've been doing that since middle school, haven't you? Cross multiplying? Okay. Oh, some of you guys are in middle school. That's right. Well, you have been doing it since middle school, right? Maybe even, I don't know. Did they teach that in elementary school?
I did that in like 5th grade.
Yeah, they might even teach that in 5th grade. Yep. I just don't remember all that stuff. I never taught 5th grade. Okay, so anyway, so watch what we got here. Let's do an example, and we'll see how we can use this thing. All right? I'll keep that up there like this. Here we go. Here's an example. 6 over x equals 21 over 31.5. Somebody got a calculator on them?
I do.
Okay. Get it out. All right, so if I wanted to solve for x, a couple ways you could do this, but the best way is cross multiply. That's what I would do. I like the x to be on the left-hand side, so I'll do that first. So what do we get? We get 21x equals, and then we'll multiply these, so it's 6 times 31.5. Look, since I got a calculator, if I got all these decimals, I'm going to wait to the very end, plug it all into my calculator at once. So I divide by 21 here, divide by 21 here. So I would just plug it in the calculator. And what'd you say you got?
9.
Got 9? Okay, so there you go. X is 9. Pretty simple, isn't it? Let me give you another one. And we're basically done. I told you today would be really simple.
It's so simple. You should give us homework.
So simple, the homework won't be that hard at all, so you wouldn't have any problem doing it. It all depends on your point of view. All right, here we go. Now, you'd be disappointed, wouldn't you, if I didn't give you homework? I wouldn't want to disappoint you. Okay. All right, here we go. Ready? If I wanted to solve for x right here, this is not a matter of just looking at it and say, just trying a whole bunch of numbers. What do? We cross multiply. Now, the one thing you have to be careful with on this is what? What do you think? If I multiply these together, what's the important thing that you do? Distribute. Exactly right. A lot of people forget to do that. You'd be surprised. Okay, but if you multiply by a sum, you must distribute it through the whole thing. So we can do that in our head. What's that going to be? 5x plus 15. Okay, multiply these. There's really no distributing here. What is that going to be? 8x. Everybody with me? Subtract 5x from both sides. That's 3x equals 15. X is 5. Okay, there you go. Pretty simple. I don't know if they get any more difficult than that or not, but that's about it. Yeah, I'm looking at it. They don't really get much harder than that one right there. Okay. I think I've covered everything. Let me just take a quick peek at this.
We don't have it tomorrow, darn it.
Oh, really? You don't have math tomorrow?
No, we have. We don't have to.
Right, Thursday. We don't. So
yeah, I'm getting my hopes up.
and you have me on Friday too. So.
What?
Yeah, they have all the
Yep.
classes that you don't have during the week.
Middle school might
So
not-
you're making me feel bad now.
We don't have to see a schedule with middle school.
I'm just giving the high school schedule. This is a high school class, so that's what I'm giving.
Yes, Mr.
Where's my book?
Oh,
Just
no,
kidding.
we
Go.
How many times we talked about that?
my small group. I used to, but I don't
All right, here we go. You ready? This is section. Shh, we're recording. Don't say bad stuff. Okay, it's 7-1, and we are doing pages 460 and 461, and we're doing 12 to 30.
12 to 30.
There you go. 12 to 30. Shouldn't be too hard. There's a lot of this kind of stuff. There's a lot. Yep, I can scroll now. Isn't that cool? Look. There's a lot of this kind of stuff on here. So remember, so look at that. Make sure you know how to do that stuff. All right?